let's kind of get started. So, stop talking, please. All right. A couple of announcement type things to kind of get started here. Number one, the most recent homework check. I'd forgotten to update the assignment that I was looking for because we had school canceled on Wednesday. So I think over break it probably still said that it was like 35 through 55 odds was due. We hadn't done that lesson for that yet. All I was looking for was 25 to 32 was the only thing I needed on the check. That 35 through 55 will be, this next assignment will be part of Sunday's homework check. So if you've already done that, that's fine. But I just want to be clear as to like what I'm looking for when. Is that okay?
Is that all that's going to be due on Sunday?
And the review. And the review. So today, we are going to do that lesson 14.3. Thursday, we're going to do the chapter 14 homework quiz. And then, I know, it's okay. And the review, work on your review and work on your half sheet. Because the test is scheduled for Monday. As always, if you're gone and are unable to turn in the half sheet, you can take a picture and email it to me at any point. That is always okay. You'll still be eligible to use your half sheet by doing that. Even if I don't have a physical copy, if you have a picture turned in, even if you're not in school that day, that's totally fine. I'm happy to take it. Everybody's cool? So Monday will be the chapter 14 test. Seniors, chapter 15 would be the last chapter that you guys will be responsible for. That'll probably be a no test chapter for you guys. It'll just be stuff that we'll deal with on on your final exam if you have to take one. Because that'll probably take us a good 3 weeks to kind of get through. That's a pretty big chapter with a lot of stuff kind of going on in there. So seniors will just, when it gets close, we'll pick a day, be like, okay, everything after here you're not responsible for. We'll get you a modified review and let you guys spend your class time kind of getting that stuff put together. Everybody okay with that? So that being said, after I have the chapter 14 test scored and graded and all that, seniors, we can start talking about, doubles and retakes and putting in drops and all that jazz. But we won't worry about that until like the end of next week, probably. Okie doke. Okay. Everybody okay with the plans here? Lexi?
I'm going to go to Cairo, so can I send you a picture of my half sheet?
Yeah, as long as it's before Monday, that is okay. Yeah. And I'll make that compromise for you guys. It should be before Friday, which is the other class taking it, but like obviously you don't have, it's hard to kind of get that done because you leave tomorrow? Tonight, yeah. So let's I can deal with by Monday.
Bro, I literally was with Charlie.
Right, like that seems pretty crummy otherwise, right? Yeah. All right.
It was amazing. Swear to God. It was really good.
Okay.
Get braces.
Oh, that's true. You better go. You better go. I swear to God. I'll come back and hurt you. No, but if I see you ever and find out. No, it's gonna be.
All right. Last topic for chapter 14. Now, this topic here should be relatively straightforward. There's not any new vocab. There's not really any new ideas here. We're just going to be looking at some technique. So I'm just going to do, I don't know, it's like 4 or 5 example problems, and that's it. So I got to show you. So it's a relatively quick one today. Should have lots of time to get started on, if you have homework stuff to get taken care of still, or Delta Math still to do, or want to work on this next homework set or start on your review or any of that. Well, you should have, an hour or so to do that. Okie doke. All right. Okay. So in section 14.3, we're going to be talking about solving inequalities. So inequalities, in almost every case, are going to have infinitely many solutions. The trick is going to be, how do we figure out how to represent those infinitely many solutions? So this is going to be the idea. So we're going to start by taking our inequality and just pretending it's an equality. So what type of an equation have I written here? It's just a vocab thing. X squared minus 4 is, starts with a Q. Quadratic. This is a quadratic equation. To solve a quadratic equation, what tools do I have available to use? To solve a quadratic, what might I use? Factoring, or the quadratic formula, your big two that you'd probably want to choose. Either would be appropriate in this case, but notice that the leading coefficient here is 1, right, which makes factoring usually pretty easy. Does anybody see how to factor this one? Great, x plus 2x minus 2. Right, hopefully we recognize that as a difference of 2 squares. Those are one of our favorite types of things to factor because it's usually super easy. I can then apply the zero product property. Since the product of those two things is equal to 0, I can set each of them equal to 0. And I get solutions of -2 and +2. I am not done, because this is really what we're solving for is an inequality. There's still some more work to do. So what I'm going to do is I'm going to draw myself a sign diagram. So I'm going to draw a little number line, and I'm going to put in my solutions, -2 and +2. And now I'm going to ask myself, do -2 and +2 satisfy this inequality? If I plug 2 in, 2 squared is 4, 4 minus 4 is 0. Is 0 greater than 0? No, right? So I'm going to put an open circle on my number line at 2. If I do the same thing with -2, if I plug that in, what do I get? Mr. Kulik, you get 0 again. And 0 is not greater than 0, so we'll put an open circle at -2 also. Everybody's okay there? So what I have now is I have 3 different places where I could get answers. I could get answers that are less than -2, between -2 and +2, and greater than 2. Everybody see that? So to figure out whether I have answers in those intervals, what I'm going to do is I'm going to pick a test value from each interval. So I'm going to pick something that's less than -2. So maybe -3. Does it matter what I pick that's less than -2? No, but don't go crazy. Like, pick something that's easy to deal with, right? I'm going to pick something between -2 and +2. So I'm going to pick 0. And then something that's bigger than +2, I'm going to pick 3. What I'm going to do now is I'm going to take each one of these 3 test values and plug it in and see if the result is greater than 0 or less than 0, if it's positive or negative. So when I plug -3 in, -3 squared is 9. 9 minus 4 is 5. So that part's positive. Any x from there is going to give me a positive output. Everybody's okay? If I plug 0 in, 0 squared is 0, and 0 minus 4 is -4. So that whole section is going to give me negative outputs. And if I plug in +3, 3 squared is 9, 9 minus 4 is 5. So that section is all going to give me positive. So because I want to be greater than 0, I want this section and this section. Everybody agree? The 2 parts that the test values gave me a positive output. So I want -infinity to -2 or 2 to positive infinity. Just as a piece of vocab, this thing that I did here is called a sign diagram. S-I-G-N as opposed to S-I-N-E. Because really all I'm caring about is just the signs for the numbers on those intervals, whether they're positive or negative. Let's do another. First step is to pretend it's an equation. And solve that equation equal to 0. Or I should just say solve that equation. Right? It had a 0 there. What kind of an equation is this? Notice the x cubed. Guys, it's cubic. Or in general, it's like a big degree polynomial, right? Bigger than quadratic polynomial. To solve a polynomial, what do I want to do? Starts with an F. Not FOIL, factor. The other F word. Not that F word, guys. So, how do I factor this? Excellent. Yeah, so Reagan's notice is the greatest common factor of x. So we can factor the x out front. The remaining polynomial now we notice is quadratic. Yay! What's nice about that? I can either factor it or use the quadratic formula. Since the leading coefficient is 1, it's just x squared. Let's factor it, because usually that'll usually work, and it's usually easier than the quadratic formula. Or less tedious, maybe is the better word. What multiplies to give me positive 4 and adds to give me negative 2? I'm sorry. Multiplies to give me positive 4 and adds to give me negative 4. Yeah, they gave it away there because I misspoke. My brain was going faster than my mouth was. Everybody's good with how that factored? Apply our zero product property and we get solutions of 0, 2, and 2, correct? Everybody's happy? Let's draw our sign diagram. So what number should be first on my number line? Zero. Why 0? It's the smallest of my solutions. Very good. What's the next number got to be? 2. Where's the next number got to be? No, nothing, right? Does it matter that 2 occurred twice? Not when I'm drawing my number line. Everybody's good? All right. Now I'm going to look at each of these solutions. If I plug 0 in for x, I get 0 minus 0 plus 0. Well, that's 0. Is 0 less than or equal to 0? Yes. So that's going to give me a filled in. If I plug the 2 in, I'm going to get 2 times 0, which is 0. Is 0 less than or equal to 0? Yes. I thought about plugging the 2 in here, just because the arithmetic was going to be way less annoying. You know what I mean? Because those are still the same thing. Those two things are equal. You know? You know. All right, let's pick some test values. So I'll pick, say, negative 1. I'll pick 1. And then I'll pick 3. Everybody okay with the values I picked? Could you pick other things? Sure, but try not to pick stuff to make it annoying, right? Like between 0 and 2, what are you going to pick other than 1? Like, don't pick no decimals here. Come on now. Not if you don't have to. All right. So I'm still going to use this to kind of think about my plugging in. So if I plugged in negative 1, I'd get a negative here, and a negative there, right? What do I get when I multiply 3 negatives together? A negative, because that's all I really care about is whether things are positive or negative. I don't care what the number actually is. I just care about its sign. That's why we call this a sign diagram. Okay, if I plug positive 1 in here, I'd have a positive, a negative, and a negative. What do I get when I multiply a positive and 2 negatives? Positive times negative is somebody take a risk. I'm going to call on you. Lexi, what do we get? Good. Why didn't you answer when I was asking for volunteers if you knew the answer? If I plug 3 in, what do I get? I get positive, positive, and positive. What's 3 positives? Still positive. Okay. So, what is my solution set now? I want less than or equal to 0. Look at our sign diagram. What part of our sign diagram is less than or equal to 0? This part here. And and 2. Right? Because what do I get when I plug 2 in? 0. All right, so how do we write this interval here? So negative infinity to 0. And then what symbol am I going to have to use on the 0? A bracket. Excellent. Why do I need to use a bracket there? I include 0 because when I plug 0 in, I get 0. And then to do just the 2, I use the set brackets, and I can just write the 2. So that's telling me the answer is anything that's less than 0, I should say less than or equal to 0, as well as 2. So far, so good? Ruh-roh, Mr. Kulik. What do you notice that's different about this one? It's no longer a polynomial, is it? What kind of an equation is this? X minus 4 over x plus 1 equals 0. What do we call this thing? It's a rational equation. Now, when I deal with a rational equation, I need to do this a little bit differently. I need to look for the x-intercepts. How do we find the x-intercepts for a rational function? I set the numerator equal to 0 and solve. And I also have to look at the discontinuities. To find those, I'm going to set the I'm going to set the denominator equal to 0 and solve. Everybody's okay there? So far, so good? Yes or no? All right. I'm going to draw my number line. On my number line, the numbers I'm going to include need to be -1 and 4, correct? Now, here I have to be a little bit careful about opens and closes. If I plug 4 in, what do I get? If I plug the 4 in, I get 0 over 5. What's 0 over 5? Zero divided by 5, which is 0. And that 0 is greater than or equal to 0, so I want that one. If I plug -1 in, I get -5 over 0. What is that? Undefined. So is undefined greater than or equal to 0? No! The discontinuities are always going to be open circles. The x-intercepts depend on the inequality, right? If it's an or equal to, inequality, then those would be filled. If it's a strict less than or strict greater than, then they would be empty, right? So far, so good? All right, let's pick some test values. I'm going to pick -2. I'm going to pick a 0, and I'm going to pick a 5. Everybody happy there? Okay. When I plug -2 in, that's going to give me a negative over negative, right? Which is, what do I get when I have a negative divided by a negative? Positive. When I plug 0 in, I'm going to have a negative over a positive. That gives me negative. When I plug 5 in, that's going to be positive over positive. That is positive. So what part gives me my answer? Right? What's my inequality? It's greater than or equal to 0, which means I want which parts? The positives or the negatives? The positive ones. So I want this piece and this piece. Now notice when I'm writing these intervals, I'm going to use the bracket for the -1, but the parenthesis for the 4. Everybody's okay there? Got to be careful with the rational functions where the discontinuities always are going to be the open circles, right?
Wait, isn't it opposite?
Nope. Bracket is included. Parenthesis is not included.
It's like -1 of these.
Oh my goodness gracious. Yeah, okay, fair enough. I was like, what do you mean? We did that. I just put them in the wrong spots. Yep, sure. Way to go, dummy. Yeepers. Thank you. Oops-a-daisy, right? All right, I think I have one more example, and then we're going to be dunzos. How's that sound? Don't sound too excited, guys. All right. So that's the square root of x plus 4 over the absolute value, x minus 1. What's the first thing I do? Pretend I have an equation. Now this is like a rational equation. So I need to take the x-intercepts and the discontinuities separate. So if I square both sides, I get x could be -4. Everybody's good with how I solved that one? Lucas, can you grab the door? I hate to always pick on you, but you're just the closest one. One of these days you'd think I'd learn to close the door at the start of 7th hour, but haven't done it yet. We don't have a lot of school left. Ugh, Mr. Kulik. All right. How do we solve an absolute value equation? Who remembers this from Algebra 2 or even Algebra 1? Nobody? Well, what you do is you break it up into two versions. One where you do the equation as written without the absolute value, and the other without the absolute value, but we negate the right-hand side, the part that's not under the absolute value. What's the good thing here, though? What's the negative of 0? Still just 0, man. Aren't these still the same equation? Well, yes, in this case they are. Okay, sure. Is everybody good? I want to review for a second there what you do with solve an absolute value equation. There's probably people that are potentially taking ACTs here this spring, and well, might want to remember how to solve an absolute value equation for your ACT, Could be helpful. All right. So -4 and +1, those are the numbers I care about on my number line. At the -4, should the circle be open or closed? Should I write an open or closed circle for -4? Remember, the x-intercepts depend on the inequality. Should be open or closed. Open because it's not an or equal to equation or inequality. How about 1? Should the 1 be open or closed? It's a discontinuity, so it's always open. It was 50-50, and you picked the wrong 50. All right. Let's pick some test values now. Everybody happy with my test values? Okay. If I plug -5 in the numerator, what am I going to get? -5 plus 4 is -1, and the square root of -1 is not 1, not -1. It's imaginary. It's I. So I'm just going to put an I there because that piece is all imaginary over there. Now, what is that going to do for our answer? It's never going to be part of an answer, right? If it's imaginary, never going to be part. Okay, sure. If I put 0 in, 0 plus 4 is 4, and the square root of 4 is positive. And then 0 minus 1 is -1, but the absolute value of -1 is positive. So that's positive over positive, that's positive. If I plug 2 in, 2 plus 4 is 6, square root of 6 is positive. And then 2 minus 1 is 1, the absolute value of 1 is positive. Positive over positive is positive. So I want both of these sections as my answer, do you have to write it as two different intervals, or could you write just -4 to positive infinity? Has to be two separate. Why does it have to be two separate? Yeah, because the one doesn't satisfy the inequality. It cannot be included. You absolutely have to have two intervals. One, the first interval ends at 1 and the second interval starts up again at 1, but neither of them include it. How do you guys feel about this? Not too bad, I hope, right? Should feel pretty familiar. And I forget what this is. Maybe it's not 33. Let me double check. Look at these problems real quick. Oh, I definitely don't want 33. 35 to 55, and we'll just do the odds. Okie dokie artichokes. For the homework quiz, I'm gonna be asking you stuff about like 14.1, which is the graphing parts. I won't ask you to graph anything, but I'll ask you to find like vertical asymptotes or x-intercepts or horizontal end behaviors or slant asymptotes or, okay, so you need to remember how to do those things from 14.1. Spend a little bit of time. Just as a heads up. Yeah, are you going to the office then? Is that what you're, okay, sure. That looks like you've been doing some hard labor or something.
What's wrong with the concrete mixer with blender?
The concrete mixer?
Yeah, like at Culver's, you like make the concrete mixer. I like cut it on the blade.
Oh. She said, I was thinking concrete like actual cement.
Oh no. Just
I'm like, who's making you run a cement mixer?
No.
And she's like, at Culver. I'm like, Culver's making you use a cement mixer? I see, like for a milkshake. Or like a Blizzard from Dairy Queen or something, right? That's what she's talking about? I see. Okay. I was very confused for a moment. It's like, what kind of job do you have?